really can't do anything with x minus 2 plus the square root of x, right? So that's just what f plus g is. Okay? So now let's look at the domain of f. What is the domain of f? All real numbers. No fractions, no radicals. Look at G now. Oops. What's the domain of G?
All real numbers are greater than or equal to 0.
Okay. What's the domain then of my operation function f plus g? So the brown one, what's the domain of the brown? What do you got? What do you got? Same thing as G? I agree with that. So the domain here then, at the end, is going to be all real numbers, but x here has to be greater than or equal to 0. Agree? Okay. So then, down here, f of x divided by g of x is x minus 2 over the square root of x. Agree? Domain of f and the domain of g didn't change. Oops, that's a bad one. Right? But now, what about the domain here of f divided by g?
All real numbers, but x cannot be anything less than or equal to 0.
No. Well, wait. Say that more mathematically sound.
X,
All real numbers,
except for anything
x
x
has to
has
be
to be greater than 0.
greater than 0. Why can't x here now be equal to 0? Because then my denominator would be 0, right? If x is 0, square root of x is 0, and I got a 0 in my denominator. Okay? So 0 gets thrown out. I can't have it be part, I can't put it into my function. I can put it into f, and it'll be just fine. I can put it into g, and it'll be just fine. But I can't put it into f divided by g. So that gets kicked out of my domain. thinking game. This chapter. Okay? So you need a new car, or a new to you car, I should say. It might not necessarily be a brand new car. Okay? So you go out and you're going to purchase a new to you car. Cost is going to be $15,000. Okay? With a rebate of $2,000 and a discount of 5%. Okay? What I want you to do now is I want you to calculate the cost if the dealership applies the rebate first, then the discount, or if they apply the discount first and then the rebate. Okay? Figure those out. Rebates are, they just take money. We'll say it's an instant rebate. It's not a mail-in rebate like at Menards. Okay? It's just an instant cash-back savings. So if I apply the rebate first, I'm going to take $2,000 right off the top. So now I only have to pay $13,000. Right? Okay? Now they're going to apply the rebate on that. Well, if I get a 5% discount, how much of the car am I actually paying for? Or how much of the cost of the car am I actually paying for? 95%, right? So I got to take 0.95 times 13,000. Well, that's going to give me $12,350. And you're thinking, yeah, I saved some money. Which you did. Yeah. But then you say to the dealer, whoa, 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 Slick. Let's flip those around. Let's go discount first. Discount double check. First, then apply the rebate. So if you apply the discount first, you're still only paying 95% of the cost. But that now is going to be $14,250. Then you subtract off your $2,000 rebate, and now you're only paying $12,250 for it. Okay? So you just saved yourself $100. Which, oh wait, you know what? Lensmeyers bought a new car this summer and we didn't go out for dinner afterwards. Usually when the Lensmeyers get a new vehicle, then we go right out to dinner. We didn't. Oh well. I grew up that tradition. Okay? What you've done there is you've done a composition of functions. You took one function and applied it, then you stuck that into another function and applied the new function. Okay? We're going to do composition of functions. You've already done some, but we're going to do some more of them today. Okay? So, if I said, find me k of 8, what are you going to do? Neither. What are you going to do? Plug what in? Plug 8 in for x in k, right? Not in d, just in k. Okay? So we're going to say, all right, so k here is 3 times 8 plus 2. So k of 8 I get as 26. Agree? Pretty straightforward. Find me d of 0.5. Negative 5? Yes? Okay. All right, now, what if I said, find me k of d of 3? That's how this is read. K of d of 3. What are you going to do? You're first going to find d of 3. All right, let's find d of 3 first. So that's going to be 4 times 3 minus 7. 4 times 3 is 12, minus 7 is 5. Now what? Now we're going to find k of 5. So that's going to be 3 times 5 plus 2. So that is k of d of 3 is 17. Yeah? You find me now d of k of negative 2. So first I need to find k of negative 2. So that's going to be 3 times negative 2 plus 2, which is negative 4. Agree? Then I need to find d of negative 4. So that's 4 times negative 4 minus 7. That gives me d of k, d of k of negative 2 is negative 23. Because it's negative 16 minus 7 is negative 23. Yes? Okay. Try those two. G of h of 7, h of negative 3. H of 7 first. So that would be 7 minus 2 divided by 5. 7 minus 2 is 5. 5 divided by 5 is 1. So h of 7 is equal to 1. Watch the screencast, because there's a lot of information coming yet. Okay. Yep. Okay. So now I need to find g of 1. So that's going to be negative of 1 squared. So g of h of 7 is negative 1. Yes? Okay. H of negative 3 First find h of negative 3. That's going to be negative 1. Then we need to find h of negative 1. Oops. So h of negative 3 is negative 3/5. Questions on those two? Find me k of d of x and d of k of x. What do we do here? In the first one, right? So we need to find, same process, need to find d of x, right? What's d of x? 4x minus 7. Nothing changes on it. Okay? So now, what do I need to find? K of 4x minus 7. So that's going to be 3 times 4x minus 7 plus 2. Oops, wrong way. K of d of x. (12x minus 19). Now my question to you, before you start finding d of k of x, is it just going to be 12x minus 19? Do we even have to do it? I don't know. Let's find out. Find me d of k of x. So did they end up being the same function? No. Only in special cases will they end up being in the same function. But we'll study that next week. Okay. Okay. So, now we got to find domains of those compositions. So before we start, let's ponder something first. Okay? Let's just say, I don't know what F and G are right now. Okay, I'm not even really, here, we'll even do this. Okay? So I want you to find f of g of 2. Okay? But if you plug 2 into g, because that's what you do first, right? Let's say the function is 1 over x minus 2. Well, you plug 2 into that function, and what happens? Now you got 1 over 0. Is that a value that you can plug then into f? No, can't do it. So we've got issues there. Okay? Or, if g of 2 was some value, let's say g of 2 ended up being 6, and you plug 6 into f, and that doesn't work in f, now you've got more issues. Okay? I do actually have a shirt at home that says math is hard. Okay? Got a bunch of holes in it, so I don't wear it. I still do have a shirt that says math is hard. Okay? So that's an issue. We're going to have to think a lot in this when you're finding domains. Finding domains is all about logic. Okay? Now, if I can revert back to your test that you just got back at the beginning of class, a lot of you didn't think on the test. A lot of you just did. If you would have thought, then you wouldn't have factored in a problem that said solve. Or solve in a problem that said factor. Okay? When you think, you got to stop, you got to put the pencil down, you got to focus in, and you got to think about what's going on in that particular problem. Because there's a lot of stuff going on in that problem. Okay? So, let's jump into one now. Okay? So, f of x is 3 over x plus 1. G of x is 2x minus 5. I want you to find me g of f of x and state its domain. So first, we find the function. Right? Side note, what is the domain of f?
All real numbers of x cannot be -1.
Oops, I gotta move it over. Agree? Plug in -1 and we get a 0 in the denominator. Okay? So let's put that in our memory bank. Excuse me. Now I need to find g of 3 over x plus 1. So that's going to be 2 times 3 over x plus 1 and minus 5. Side note, what is the domain of G? Because it's got no fractions, it's got no radicals. Okay. So now let's work on this one. Distribute the 2 in. If I distribute the 2 in, what do I get? 6 over x plus 1. The 2 only goes into the top. I want to end up up combining those, right? What do I need to have in order to combine them?
Put 5 over 1.
No. I gotta have common denominators. So what's my denominator? X plus 1. So I need an x plus 1 down here, which means I need an x plus 1 up there. Right? Because those then could factor out and I'm still left with 5. But now it looks prettier. So this is 6 minus 5 times x plus 1 all over x plus 1. So g of f of x, which is what we wanted, is equal to 6 minus 5x minus 5 is 1 minus 5x over x plus 1. Right? Looking at that one and just this brown one, what is the domain of g of f of x? What's up? Six minus 5x minus 5 is 1 minus 5x. You could have also wrote it as negative 5x plus 1. Okay? So looking at the brown, what's the domain? Negative 1, right? Okay? So now I've got to look at those 3 domains and come up with a domain for my composition function. So the domain here is going to be all real numbers. For sure, x can't equal negative 1, right? Okay? But now I have to go back and I have to look again. So my inside function was f of x. My outside function was g of x. Okay? So I'm taking values of f and I'm putting it into g. Are there any restrictions on g? No, no restrictions on g. Okay? So therefore there's no values of f that would not make g work. So there's no extra restrictions that I have to go into. So this then is my, oops, I don't know why it does that today. Jumping around. Okay? On a side note, if I went the other way, if I went f of g of x, right? So then that would be, was it 1? Nope, it was 3. So that'd be 3 over this. 3 over 2x minus 5, then plus 1. So my function here would be 3 over 2x minus 4. Right? Okay? So then the domain of f still would be x, all real numbers, but x can't equal -1. Right? Domain of g still is all real numbers. Domain of my composite function, or my composition function, now is all real numbers, but x can't equal 2. Right? Okay. But now I've got to go back and I've got to look. Well, f here was 3 over x minus 1. No, x plus 1. Excuse me, x plus 1. So if I find values of g, g was 2x minus 5. Well, 2x minus 5 can't equal -1. Because if 2x minus 5 is equal to -1, then this is equal to -1. And then I've got 0 in my denominator again. With me? Okay. So from the start, x can't equal 2. Because if x is equal to 2, g of x gives me a value that makes f of x not work. Okay. Now, if I start with -1, if I put -1 into g, I get -7. Right? Right? Does -7 make f work? Yeah, it works. So my domain here on this one would be all real numbers, but x can't equal 2. Because the -1, I can plug it into g, and it works. Because I got to start with that. Okay? It's a thinking game. You got to think about what's going into what and what's coming out. Okay? And we'll go right to this one. We're good for today. Okay? This is due on Tuesday. And there is no formative tomorrow.